let's see if we can find the second derivative of this circle x squared plus y squared equal 1. First of all, rather than explicitly solving this for y and having the plus minus, we're going to use implicit differentiation. So the derivative of x squared is 2x plus the derivative of y squared is 2y times the derivative of y, so that's dy dx, and that equals the derivative of 1, which is 0. We can solve this for dy dx, so if we move the 2x over here and then divided by the 2y, we would have negative x over y, and we've seen that part before. But now to find the second derivative, let's take a derivative of that. All right, we've got a quotient rule, so we have bottom times the derivative of the top minus the top times the derivative of the bottom, which is dy dx, all over the bottom squared. Now let's see what we can do to simplify this, and we don't want that derivative in there, but we know what the derivative equals, so we can substitute that in right there, and we would have the second derivative, whoops, I didn't get a 2 on there, equals negative y plus x multiplied by x over y squared. Now let's simplify this complex fraction. So if we made this a common denominator so we could combine them, we see we have negative y squared minus x squared, which I can write as a negative x squared plus y squared for the numerator, and then the denominator is going to be y cubed because our denominator is y, and then we can invert and multiply that, so we'd have 1 over y squared. So our denominator ends up y cubed, but this numerator, the reason I factored the negative out is because we know that x squared plus y squared equal 1, so we can replace that with a 1 and have negative 1 over y cubed, and there is our second derivative.